Okay, so thanks for inviting me to talk. Alejandro J. I'm the CEO and co-founder of OWiC Technologies. So I did my PhD here at Cornell with my two co-founders, Paul McEwen and Al Molnar, where we developed the tech that led to this startup. Okay, let's dig right in. What's the problem that we're trying to solve? So the large-scale problem that we're trying to solve is that most objects are totally disconnected from the digital world. So, as I say, almost all objects that you would hold in your hand have no link to all the valuable digital information about them that could be online. So you can imagine this is true for anything from things you buy off of Amazon to the objects in your house or office. But I'm going to give you a specific example that's a little bit innocuous of a simple bolt. How could you access the digital content related to something as simple as a bolt? By pointing to it. And who could care enough about the digital content related to a bolt to want to do that? Well, Boeing has a lot of interest in fasteners as one example. So they have digital models of every single bolt and fastener that they use in planes and where it's supposed to be installed. But at the same time, they still end up with the wrong parts installed just due to human error. They actually have a term for this called regret cost, and it's on a line of 70K per minute to fix errors that happen because somebody put the wrong part in the wrong spot or they failed to put a part in the correct spot. So what they'd love to have is some simple way for an engineer to look at every bolt, every part, and just know immediately, where should it be installed, what is it, and have some sort of digital record verifying that. So what's the solution that we're working on at OWiC Technologies? Basically, our idea is, try and connect any object you have to its related digital content, but use a microscopic tag and a handheld reader to do it. So you can imagine putting one of our devices, which are called an OWiC, on any object, pointing at it with this little reader, and pulling up digital content to a smartphone, a tablet, or eventually even something like smart glasses. And this is basically Googling by pointing. You have some laser pointer, you pointed the object, and you get that digital content. So what's the the underlying magic here? That OWiC is an optical wireless integrated circuit. So it's the chip that you're looking at on the left-hand side is about 100 microns on the side. It's got about 1,000 transistors on it, and it's able to communicate in and out using light. So the key innovation that makes this possible is instead of using something like radio frequencies to couple to such a small object, like you'd find in RFID, we use light to power it and the near infrared light to communicate out with it. So if you shine light on this little tag, you get a unique ID that's blinked out of it that you can link to digital content. And the idea itself has been around for a while, but actually integrating all the pieces into such a small device had not been done before. And that's the technology that we developed here at Cornell to be able to put both a photovoltaic for light harvesting and a micro LED and a CMOS chip all in the same small scale package. And this is more of a technical audience, so you have some sense of how small is, but I'm going to give you a sense of how small an OWiC is. So this is one of the devices that we built, the first prototypes that's on the tip of my finger. And if you zoom in, you'd see an OWiC on a single finger ridge. So as Amit was saying, fingertip ridge is about 100 microns on a side. That's about the same size scale as the devices that we're making, these small tags. And you can imagine that, small size scale, you have a small enough area that you can put it on basically anything. But it's also the key to how you make something that sophisticated, cheap enough to put on an object like, a bolt. So I don't have to explain to this audience, but, this is semiconductor processing. If you make a tag that's about 100 microns on the side, you can fit about 1 million devices on an 8-inch wafer. So the image you're seeing on the right is actually me holding one of the 8-inch wafers we got back on our first tape out for the circuits that go into making OWiCs. And again, about 1 million devices fit on that wafer, meaning that each tag is only costing us about a penny per tag to do that piece of the manufacturing. And just to close out on where we are right now, so we're funded primarily by an NSF SBIR phase 1. And we've picked up some funding from the Ben Daniels Venture Competition and the NSF I-Corps that have funded the company so far. And at the moment, we're in our final stages of the first prototype tags and the reader itself. So we've done that first tape out and are integrating everything up at the moment. And we're hoping to have our first demo in the next week or so. Customer discovery, so we did the NSFI core to interview about 130 different customers. And that's led to some initial conversations with potential partners. So we're currently talking to Lockheed Martin, Boeing, and Vertiv to see if there's a good fit for the technology and their aims. So with that, I'd like to open the floor to questions, and if not now, I can talk in the breakout room.
Thanks, Alejandro. One question. Kevin asked, durability from impact, heat, etc.
Sure. Yeah, so the tags themselves are totally encapsulated in glass, either thermal or TIOS, which means these things are, incredibly robust against high temperature, low temperature. It's encapsulated. It's effectively like a little grain of sand, so it's pretty robust against the elements. We have one design even on the academic side that's recording neurons inside of the brain of a mouse, so it's pretty robust.